Question 7. We have our function y squared e to the xy with the parameterization that x is 1 over t and y is t squared. We want to verify that this equation is true. So the first thing first, let's start working through on the right hand side. So we'll take the partial derivative of f with respect to x, which we can work out as y cubed e to the xy. So same as f, except we've had to bring down the coefficient of x, which is y, hence why it's y cubed. Then we've got dx by dt. So looking here, we can say that that is negative 1 over t squared. If you think of that as t to the minus 1, multiply it by the power, so minus 1, and then decrease the power by 1. Then we want the partial derivative of f with respect to y, which we have to use chain rule for. So first we're going to differentiate y squared, and then we're going to differentiate e to the xy, which is just x e to the xy multiplied by the y squared. And finally we want to find the derivative of y with respect to t, which is 2t. So now we can come up with an expression for the full right hand side. So we have y cubed e to the xy times by negative 1 over t squared plus 2t lots of 2y e to the xy plus xy squared e to the xy. And that is equal to df by dt, which we haven't worked out what it is yet. So let's work out what that is. So because we've only got f in terms of x and y, first of all we need to parameterize so that we've got f in terms of t. So f is equal to y squared, which is t to the 4, times by e to the xy, which is e to the t. And we can now differentiate this with respect to t. Full differentiation, not partial differentiation. And that will give us 4t cubed e to the t plus t to the 4 e to the t, just by the chain rule. So now we can equate this 4t cubed e to the t plus t to the 4 e to the t. And now we've got the left hand side is in terms of x, y and t. Right hand side is only in terms of t. So we want to get the whole equation in terms of t now. So we'll simply parameterize everything else on the left hand side. So y cubed is t to the 6. E to the xy is e to the t, and that is all over t squared, or negative t squared I should say. And then we're going to add that onto 2t lots of 2t squared e to the t plus xy squared, so y squared is t to the 4, x is 1 over t, so that's t to the 3, e to the t, and then that is equal to our expression here. Tidying this up a little bit further, this gives us t to the 4 e to the t plus 4t cubed e to the t plus 2t to the 4 e to the t. And again, we can tidy that a bit further, so that is a negative. That combines with there, t to the 4 e to the t, leaving us with 4t cubed e to the t plus t to the 4 e to the t, which is equal to df by dt. So here we have parameterized in order to verify this equation at the top. I hope you found this useful. Thank you for watching.